Welcome to Teddy Talks. We are looking at more examples on lift problems. Now here they say a man whose mass is 70 kilograms stands on a spring weighing machine inside a lift. When the lift starts to ascend, its acceleration is 2.5 meters per second. Calculate, should the word calculate here. Calculate the reading of the weighing machine. 2. The reading of the weighing machine when the velocity of the lift is uniform. 3. The lift, when the lift comes to rest with a retardation of 5 meters per second squared. Now, let's look at the solution. They are saying a man stands in a lift and it is ascending. When we say the lift is ascending, it means that if this is the lift and this is our man, the lift is moving upwards with an acceleration that is equal to 2.5 meters per second. But we said on this man, there is a normal reaction. Now for upward motion, we did say that the resultant force or the net upward force that we call MA in line with Newton's second law is equal to R, which is the tension in the spring minus the weight of the man. Now, they wanted the weight of the reading of the weight, of the weighing scale. The reading of the weighing scale is the resultant force. It is the reaction or the tension in the string. So we make R the subject and we see that our R is equal to MA plus mg. So the reading on the spring is going to be 70 times 2.5 plus 70 times 9.81. Therefore, the reading is going to be, we compute, is 70 into 2.5 plus 9.81. This gives me 861.7 newtons, and that will be the reading of the weighing machine when the lift is ascending. Now let's look at Roman numeral 2. It has two parts, A and B. Part A, they say that we should get the reading of the machine when the velocity of the lift is uniform. Now we say for uniform velocity, acceleration is equal to 0, and therefore it means that our reaction here is mg is equal to ma, but a is 0, which implies that the reading on the lift is the actual weight of the man. So this will be 70 times 9.81, and this value of ours will be the weight or the reading on the weighing scale. So this is 70 times that. This gives me 686.7 newtons. That will be the reading of the man. Now, the lift comes to rest with a retardation of 5 meters per second. Now, when does the lift come to rest? It means that it is moving downwards. And we realize that for downward motion, the reaction is equal to mg minus ma. Therefore, our R is m into g minus a. Therefore, R is equal to 70 into 9.81 minus 2.5. And this one gives me, compute 70 into 9.81 minus 2.5. This gives me 511.7 newtons. So we have answered our question successfully. Here we are saying when they say it is retarding, it means it is moving downward. So here we say for downward acceleration, we can add and say that for downward acceleration. For downward acceleration. So this was the way to go about that question. Thank you.